So we'll be talking about two things in this video. The first thing is how to prove a theorem. The second thing is how to apply the theorem. Now the theorem we're going to be focusing today is angle at center is twice the angle at the circumference. Okay, so to prove this theorem, we have to use another theorem. The theorem we're going to be using is exterior angles of a triangle is equals to interior sum of angles. Now, it's very important that you know how to use that because you're going to use it in this particular theorem. So let's get into it. Let's get into the theorem right now. So now we'll be proving the statement that if an arc subtended by an angle at the center of the circle and at the circumference, then the angle at the center is twice the size of the angle at the circumference. So from the statement and the theorem we're trying to find, we're trying to prove that AOB is equals to 2ACB, and it is given that O is the center of your circle. So the goal is to prove that angle at center is equals to twice the size of the angle at the circumference. Now, when you're proving the second theorem, one thing you need to always remember is that it could look like any of the three diagrams. Now, to construct, the first thing we do is to draw a line through C and extend it past O. The next thing to do is to label. I'll label that 1, I'll label that 2. Same thing, I'll label this 1, and I also label that 2. I could also call this, let's call this D. So what I just did is to prove this statement, we'll be using exterior angles of a triangle is equals to the sum of the opposite interior angles of that triangle. So let's start the proof. The first statement is O1 is equals to the addition of C1 here and B1 here because of the exterior angle of a triangle is equals to sum of the interior opposite angles. The next statement is C1 is equals to B. Now we notice that COB has two lines that are equal. We have OC and OB. They are both radiuses. And because they are radiuses, therefore, it's an isosceles triangle. An isosceles triangle is a triangle which has equal sides. Now, if your sides are equal, the opposite angles of those sides will also be equal. The angle you have at B will be equal to the angle you have at C. Since C1 is equals to B, we'll replace B with C1, then substitute it back into the equation. Now, this here gives us what we have for this first triangle over here, the triangle COB. O2 would also be equals to 2C2. So after we've gotten O1 is equals to 2C1, we do the exact same thing for the other triangle COA. And when we do that, we are going to get this. If you add those two answers that we got, you would have this is how you would prove the statement angle at center is equals to twice angle at circumference. With the theorem in mind, let us try out an example that will help you put all this in perspective. And that's up next. Now, to answer this question, you have to have an idea of angles around the point. Sum of angles around the point add up to 360. And we're going to use that in answering the question. The first thing we understand over here is that O1 plus O2 is equals to 360. The reason is sum of angles at a point. We will replace O1 with 120, and by calculating O2 will be 240. With the help of angles at center is equals to twice angle at circumference, we understand that So since O2 is 240 and BCA is x, we can find x now by dividing, and your x will just be 120 degrees. So this is how you apply the theorem: angles at the center of the circle is twice the size of the angle at the circumference. I hope this helps. When you're using this particular theorem, it's very important that you write the reasoning like what you see on the screen. Angle at center is equals to twice the angle at the circumference. And that's it. If you have any question, please direct it to the comment section below. I'll try my best to answer you. You could also check out the playlist for other videos on Euclidean geometry. And on your way out, please don't forget to like and subscribe. Thank you.